Hello friends and welcome to Edupedia World Videos. Today we are going to start the chapter 1 of the course Basics of Programming in C language. The chapter 1 tells a brief history of programming languages and it will tell us how the C language actually evolved. Initially, as we all know, we must have studied about abacus. The computers were of the form of a wired frame on which beads used to be there, and you can move those beads and perform your countings and calculations. After that, they slowly evolved into mechanical devices in which the dials were there, so you could rotate those dials to various numbers, and this served as your input. And then, after pressing a button, the output dials would rotate to point to your output digits. So that those used to be calculators which used to operate mechanically. And later on, during the time of World War II in 1940s, the first electrically powered computers were created. And at that time the computers used to be humongous. They used to be occupying a whole space like 20 by 20 feet room completely, and programming used to be a very tough job because it was not like today's world where you had a monitor and a keyboard and a mouse. At that time the output and input both used to be using punched cards. So punched cards are cards on which some holes were punched, and these holes were read by the computer, and the output also was generated in forms of punched cards only. So punched cards could be read only by the experts, and then they used to interpret the output out of those. But gradually, as computers became more evolved, the output turned into a monitor as we see it today. And in those times, the initial programming languages, which were known as the assembly languages or low-level languages, these evolved. So programmers would first write a program in assembly language, and then they would convert it into a binary code and finally input it to a computer using the keyboard. The assembly languages were also known as low-level languages. Okay, so here is a screenshot of assembly language code. The code in the low-level languages comprises of special keywords known as opcodes, which is nothing but a short form for operation codes, and numeric values. So every instruction, as we know in programming, must contain two things. First is the operation, what operation has to be performed, and the second is the numeric values, on which numeric values the operation has actually to be performed. Or these numeric values could also be stored in certain memory locations. So in that case, we used to pass the memory locations to the opcodes. Here we can see that these in this line vertically are the opcodes. JMP means jump, so jump to the memory location 0036, so it would straight away take your code to the memory location 0036. And this is CMP, compare, which will compare these two operands. These are the operands and this is the opcode. Okay, so this is how the code in assembly language used to look like. So this was also very complex and tough to understand for normal people. So you used to have a lot of knowledge in the field of computers to understand this kind of code. And not only that, but the time taken to make such kind of code was also very huge. So first they need to write the code in assembly language, then they need to convert it into bytecode, then they need to input it to a computer, and then they used to check the output. And the output was also, in the first time, if the code does not run, then you have to debug it, and debugging was also a very tough task. So all this led the programmers to think that they need to make their time to program very fast. So for that, what happened was the high-level languages evolved. A high-level computer programming language is the one in which the programming instructions are just like human readable statements. So these are written generally in English-like words. Okay, so the code written in high-level language is first converted into machine language by a process known as compiling. So internally, what happens when you write a code in a high level language, you have to use a software known as a compiler, which will read that source code. Now this code which you have written in a high level language is known as source code. So now this will be read by the compiler, and compiler will convert it into an object file, which will be the machine language code which the computer will understand, and that will actually execute on your operating system. So the compiled code can then be executed by the operating system. Okay, so if we go to the next slide, the high level languages, the first high level language was John Marsh's short code. So it was proposed in 1949, and its instructions were similar to common mathematical statements, just like A is equal to B plus C and so on. So this was the first high level language in which the programmers did not have to write the actual assembly language code. They used to have just used to write just mathematical instructions, and then it used to get executed. But the problem with shortcode was that every time the code is executed, it was first converted into machine code, and then it used to be executed. So it used to take a lot of time to execute your program every time. So gradually the concept of compilation came up, and as we studied in the previous slide, that nowadays code is first compiled by a software known as compiler, which generates the machine language code. So now you can always run that machine language code without the need of compilation again. So since then the computer languages have been evolving, and their instructions have become more and more simple and readable. Okay, now we come to C language. C language was developed by Dennis Ritchie and Ken Thompson during the year 1972 to 73 at the Bell Labs. So what happened was that initially they had a language known as B language. This was also developed by the same group, Dennis Ritchie and Ken Thompson at the Bell Labs. So they were working on the language B, and now they had a requirement to develop a new operating system, which was Unix. So they were using B language to develop this operating system Unix, but gradually they found out that B language, it did not give them such a rich feature set that they can write a whole operating system in it. So to solve this problem, they had to write a much advanced language which was known as C language. So C, the name was just kept sequentially after B. They kept the name as C language. And during 1970s, they completed the work of Unix operating system, which was completely written on C language. Okay, so this we have already discussed, and gradually after that the C has then turned into a very efficient systems programming language. Okay, so these are some of the features of C language. C is a middle level language. So C is neither a high level language nor a low level language. Why so? First thing is that C has the features of both languages, high level as well as low level. C can support direct access to CPU registers. So CPU registers are some registers available with the CPU to store some values while processing. So C language has a capability which is supposed to be the capability of a low level language only, that it can straight away access the CPU registers, and it can also access straight away the memory locations, which we know that the concept of pointers is there in C language, which we will study throughout our course. So that is why also C is a low level language. But apart from this all, C supports English like human readable keywords. Because of this, C is a high level language. So all these features make C a middle level programming language. And C is also a structural programming language. So what does that mean? We will explore it throughout our course content. Okay, so C is also a highly efficient programming language. C, because it has straight away evolved from the assembly language, it is very efficient. And the next point is that C is not a system portable language. That means that if you have an IBM computer and you compile your source code on that computer, and now you want to run it on a Hewlett Packard or HP computer, will not be able to run it. Why? Because the C code will again need to be compiled on the HP architecture so that it can run on that computer. So C is not a system portable language. So this is a slight disadvantage of C language. So why should one study C language? Okay, so let us see why should one study C language. First thing is that C is simple and easy to understand. So it is one of the first programming languages, one of the first high-level programming languages. So it is obviously very simple. And C is the most efficient high-level language available with us till date. So hence it has been used a lot in system programming, in systems programming. We, for example, the whole operating system Unix is written in C language. Okay, so syntax of C is copied by other modern day programming languages also. So if you are versed with the syntax of C language, it will not be difficult for you to learn other programming languages because they copy the syntax from C only. Like PHP, a very popular web development language these days, it has a similar syntax to that of C. Okay, C is reasonably close to the machine. So we have already learned that in C language you can straight away read the CPU registers, you can point to various memory locations. So the concepts of pointers, bytes, and individual bits that you can access and manipulate through C language, it helps you to learn a lot about the software that is working underneath the hood. So about how each action is happening, you can not only learn about it but also optimize it. Okay, and further, the C is also very widely used in embedded systems programming because of its efficiency. So all those who are more interested in creating new products, new innovations, especially the electronics in the electronics field, are also encouraged to learn C language because it is most widely used in embedded systems programming. Okay. Thanks for watching the chapter 1 of Edupedia World videos.